All right, here we're going to be talking about the interior and exterior angles of polygons. We're going to focus mostly on regular polygons, but we're also going to just talk about it in general. So an interior angle is formed at each vertex of a polygon, and it's inside the figure. A polygon is just any sort of closed shape. Any number of sides is fine as long as it's closed, which means it doesn't have any openings in it. Then it's called a polygon. So triangles can be formed inside to show how to find the sum of all interior angles. So we're pretty familiar with triangles at this point. We know that that has 180 degrees on the inside. Quadrilaterals, we know it has 360. And there's a really clear, easy way to see this. If we split this quadrilateral into two separate triangles, we've got a triangle there and a triangle there. The sum of these angles we know is 180. The sum of these angles we know is 180. So together, that's got to be 360. It's 180 plus another 180. We're going to kind of just keep that pattern going. I'm going to connect one vertex across to form triangles. Now I have 1, 2, 3 triangles. So I have 180 degrees from this guy, 180 degrees from that one, another 180 from that one. That's a total of 540 degrees. Hexagon, which has 6 sides, that's 5 sides for pentagon, 6 sides for hexagon. A heptagon has 7. We're just adding one side each time, and we're going to add one triangle each time. From that vertex, I can connect it across to these other 3 vertices, giving me 1, 2, 3, 4 triangles, each with 180 degrees. So that has a total of 720 degrees. Hopefully you can see the pattern. Every time we add a side, we add another triangle, and we add another 180 degrees. I'm going to show it one more time. 1, 2, 3, 4 triangles there, or sorry, 4 lines there, creating 5 triangles. 2, 3, 4, 5 triangles, which means we have 5 times 180, or 900 total degrees in that heptagon. So that's all of the interior angles put together. So where n is the number of sides, we're going to do n minus 2 times 180. It's 180 times the number of sides minus 2. So however many sides we have, let's say we have 3, we can do minus 1 from that, times 180. That shows us the simplest example that I'm sorry. I wrote 1 there. I was getting the answer there. 3 minus 2 is 1. So a triangle has 180 degrees altogether on the inside of that shape. So we're going to try a couple of these. Doesn't matter if it's a regular polygon or not. It can be a weird looking one, or it could be a rectangle. A rectangle is not a regular quadrilateral. A square is really a regular quadrilateral. So we have 4 sides. We do 180 times 4 minus 2 to find out that a quadrilateral or a rectangle, any 4-sided shape, has 360 degrees altogether with its interior angles. This shape has 1, 2, 3, 4, 5, 6, 7 sides. So I'm going to do 180 times 7 minus 2. This is just a heptagon, which we actually already did. 5 times 180 is 900 degrees. Try the rest of these on your own. Really just following that formula for each of these. And now we'll get to exterior angles. An exterior angle is formed, or they form a linear pair with each interior angle of a polygon. So I have an interior angle here. If I continue this line, it forms a straight line and therefore a linear pair with that interior angle. That's called an exterior angle. This angle here is the exterior angle, which creates that straight line with the interior angle. We actually can do that both directions. That's what's shown here. You can go that way, you can go that way. Either way, you're getting the exact same angle. You can see that those are vertical angles, so they have to be the same. When we consider the sum of all the exterior angles, we don't consider these as 2 different angles. We're really just thinking about going one direction, like we're seeing here. The sum of these exterior angles is super simple. It's just 360 every single time. All of those exterior angles added up has to be 360. You can see it maybe the easiest with an example of a triangle or a rectangle, maybe even easier. If these are 90, then you extend them. Those are also going to be 90. We still have 4 of those. So the exterior angles are going to add up to the exact same thing as the interior angles. As we add sides, our interior angles will grow and our exterior angles will shrink, keeping this number at 360. So it will always remain at 360 for the sum. These couldn't be simpler. The sum of these exterior angles is 360. The sum of these exterior angles is also 360. Now we'll get into regular polygons, and they have a special feature to them. Actually, all the sides, and here I'm just going to be talking about the angles, but all the angles are congruent. All the interior angles are congruent, and therefore all the exterior angles have to be congruent also. So, to find the measure of each interior angle, we're going to find the sum of all of them, which is 180 times n minus 2. That's all of the angles put together, and then we divide by how many actual angles we have, how many vertices we have, so we divide by n. The number of sides, the number of vertices is the same. So you divide by the number of sides, that tells you what's the measure of each angle. Similar kind of logic for exterior angles, except it's a little bit simpler, because we know that those are going to add up to 360 altogether, and we just divide those evenly among however many exterior angles we have. So we're going to find the measure of each exterior angle here. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 360 divided by 10 tells us that each exterior angle here, like that one, or this one, each of those is 36 degrees. You can also work backwards from that. Once you know the exterior angle, if I know that this is 36, that this has to be 144. So the interior angle there, like that, or like that, has to be 144 degrees. Same thing for each of those. 1, 2, 3, 4, 5, 6, 7, 360 degrees, divided by those 7 angles that I have. Tells us that each of those angles is about 51.43 degrees. Keep going with these exterior angles, and then pick up with the interior angles, although I kind of already went over this. I'm actually just going to show one of these. To get this, we're going to find, you could just find the exterior angle and then work backwards from the supplementary angle, or you can find the sum of all the angles, 1, 2, 3, 4, 5 angles, 5 sides really, minus 2. Times that 180, that's going to tell us all the angles put together, and then we just divide by how many sides we actually have, so we'll divide by 5. So 180 times 3 is 540, divided by 5 is 108. So each of these angles is 108 degrees. All right, that is angles of polygons. If you get stuck on anything, rewatch the video, ask your friends for help. Keep trying.